Hello guys, today we are going to try to enter a new world. A new world, what I mean here is that in natural numbers, this equation has a solution like x equal 5 because 5 is a natural number. But this equation has no solution in natural number. No solution in natural number. But of course we know that this equation has a solution in natural numbers. I mean integers, okay. So what is it? It is minus 5. But minus 5 is not a natural number, but an integer. So it has a solution. But after some time, like this has no solution in Z. And no solution in natural number as well. But we know that this guy has a solution in rational numbers, like this. This is rational number, this is integers, this is a natural numbers, so I'm sorry, that is real numbers, for real numbers, that is rational numbers. Yeah, there it is. This is the rational number, so it has solution like minus 5/2. That's our solution. Let's continue with real numbers like, square and square roots. Like this equation has no roots in natural number, no integer solution, no rational number solution, fractions, none of them. But this guy we know, the minus 1, of course. The minus 1, not the positive one. The minus 1, we all know that this has a solution, like, okay, let me write this. No solution in Q, no solution in Z, no solution in natural numbers. But this guy has a solution like x equals plus or minus square root of 5. So these are the real numbers. So up to now, the numbers we know to this point, all of them are real numbers. These are real numbers. And there are some irrational numbers as well. So natural numbers, integers, fractions, irrational numbers, and real numbers. So this is the whole thing we know up to now. But let's start with this equation. X squared minus 9. It is a solution like x1 3 and x2 minus 3. And it has a graph like this, minus 3 and 3, and it goes like this. If you put it 0, then this is the minus 9. So it has a solution. Let us continue with x squared minus 4x plus 4 equals 0. This is a this is a square of something. This is the square of it. And if we try to find the solution of this this equation, it equals 2 and 2. So it has two roots. It has two equal roots. And if we try to draw its graph, we find it like this. The y-axis can never be 0 because it is square root of all over the x. And if we put 2 in x, then we get 0, like this. So this is the graph of this equation. But what about that one? X squared plus 9. What about this guy? So if we try to solve it like this, minus 9, if we square root of both sides like this, x equals minus 9. What is that? Until now, we say that there is no such a thing in real numbers, but in 17 or 1800s, Carl Friedrich Gauss has found a definition for this number. So let me introduce you our new term for this number to be defined. We define an imaginary number. So we call this number is our I. I equals minus square root of minus 1. And if we square it, we get minus 1. And here we put it in the x like this. Minus 1 and 9. We can write it like this and continue like this. Minus 1 and 9. And this is, we know that is 3. But it's it's x like this. X here also is like this. So x is either, this guy is I, x is either 3i or minus 3i. Hey guys, I hope you found this result interesting, because up until now we said these equations have no solutions in real numbers, but in real numbers, this is the important part. And now we found that these equations have also solutions, but not in real numbers, in other system actually. In the past, we have some equation doesn't have a solution in natural number, doesn't have a solution in integers, doesn't have a solution in rational numbers, and every time we don't have a solution in these systems, we expand our system in order to have a solution in new systems. So in real numbers, x squared plus 9 equals 0 has no real roots, and we want to find a solution to this equation, and so we expand our system to another system. And in this system, by introducing I equal to square root of minus 1, we can find solutions to those equations. Isn't it interesting? See you in the next class. Bye bye.